Okay, so we have to figure out, well, that's a big highlighter. Sorry, let me change that for you. Okay. We need to figure out if this is going to be a sine curve or a cosine curve. And so here's what I see when I look at this, okay? I see a starting point there and an ending point here. And so the part that I'm highlighting here, this highlighted part, for me, that's a sine curve. And the reason that's a sine curve is because it starts at 1, goes up, goes to 0, goes to -1, and then goes up again. So for me, I'm going to be looking for a sine curve. So I'm going to go ahead and write down, all right, I know I'm going to have the sine of x. Then from there, I'm going to go ahead and draw the midline, okay? And the midline means I've been pushed up how many units? That's been pushed up 6 units. So I know I'm going to have the sine of x and then a plus 6 somewhere along the line. Or the 6 could also be in the front. Okay, now I have an amplitude. The amplitude is the distance from the midline to the top and the bottom. Those have to be the same. That's a value of 1, 2, 3 units. So now, these are all y equals, by the way. So now I have y equals 6 plus 3 times the sine of x, okay? The last thing I have to do is figure out the period. So you'll notice that it started here, right? Started here and it ended here. Well, if I transpose that down to the x-axis, that's a distance of pi. So my period, yikes, sorry, my period is pi. So that means you got to ask yourself, okay, 2 pi divided by what w value would give me back a period of pi? Okay, and the answer here, of course, is 2. W has to be a 2 because 2 pi divided by 2 gives me back a pi. So 2 is what goes into my equation, and it goes in between the trig function and the x value. So my final answer is 6 plus 3 times the sine of 2x. Yes.